All right, welcome back. Good day to everything mathematics. Today we're continuing our series on factorization, and today we are going to be looking at completing the square of course, a quadratic equation. No expression, I can't remember. But when a is equal to 1. Good. So what's our objective today? Factorizing by completing the square when a is equal to 1. So I'll be showing you how to complete this square and how to do it more so when a is 1. And in tomorrow's video, you could call it part 2 if you so wish, we're going to look at how to factorize completing the square when a is not equal to 1. So that means there's a value for a. Good. So let's just first understand the standard or know what is the standard form of completing the square looks like. So the standard form looks like this. So we have a into x plus h all squared plus k. A of course would have been the coefficient of the x squared term. The h would be what you will call your half of b. You'll understand that in time to come. And your k is known as your constant in this case. One thing you should know, and I just jump in a big gun here, but when you put your h and your k, when you solve for h here, along with your k here, what you actually have in a quadratic is it's known as your vertex. Or, for want of a better word, I would call that your turning point. Good? And that is what your turning point. That is what these two values are. So that's one of the things that you need to understand about completing the square. When you complete the square and you solve it, when you reach this stage, you automatically will end up with your vertex. And that's one of the beauties of completing the square because it ends up with that value. And you might want to know what's the importance of the vertex or what's the vertex. Okay, simple. Remember, when you have a quadratic equation, when you draw it, it will either look like this or it will look like this. Of course, you could have scenarios where it looks like this or where it looks like this, but you hardly see this at the CSEC level. That's higher level maths, right? But naturally, we have a U-looking shape or an upside down U-looking shape. And the vertex, aka your turning point, will always be the value of the minimum value or the maximum value. So let's call this one the minimum. Let's call this one the maximum. Or of course the turning points. So this is one of the beauties that we get from solving an equation by completing the square. We could literally find that minimum value or the value where that graph turns from down to go up. And likewise, we could find that maximum value from the point, that is the point where the graph turns from right up and it goes back down. So that's one of the things we get from completing this square, right? Of course, from yesterday's video, when we look at factorization, factorizing a quadratic equation, you should have learned that from that, when you solve it, we get our roots or our x values. So if I have again a graph, and again, let's say my curve looks something like this, by factorizing the equation, I could know what is the value at this point here and the value at this point here. But by completing the square of that same equation, I could know what is my turning point. And those are all handy little tricks you need to know so that in case, you see, they could ask you to do that. They could ask you to sketch a graph. These are things that you need to be able to figure out. So to sketch a graph, of course, you need your two roots or your solutions or the cutting the x-intercepts, if you might want to refer to them like that. And then you also need your turning points. Your turning point meaning your vertex. Good? That was just additional information. I don't even plan to say that today. Let's talk about now the process of completing the square, which is the highlight of this video. The process of completing the square. What do we do? First of all, we pair our x terms together, and that's simple enough. Again, I'm just stating the facts here. We're going to show it after. Then, of course, step 2, and this is the most important and trickiest thing to do. Actually, it's very easy. It's only tricky when you're dealing with a fraction, but it's really and truly very straightforward. You find half of b. So whatever b is, and remember, b is the coefficient of x squared. So generally, remember, we have ax squared plus bx plus c. So the b we're talking about here is b here, whatever is the coefficient of the x term. Good? So you find half of that, you have to square it, and then you add it on the inside, and you subtract it on the outside. And don't worry, it sounds high-tech when written. When I show you, you will understand that a lot better. And of course, after that, we just simplify and we solve the question. Well, of course, that's given that it's equal to 0. Good. So let's jump straight onto it. So let's do them by step. So we're given this equation. Step 1, they said we have to pair our x terms. So here we have x squared and we have 6x. And notice x, just highlighting it, our x squared term here has a coefficient. This coefficient is generally a, remember that in the standard form. And in this case, because there is nothing, that's what makes it a equal to 1. So when we do this now, the second step states that we find half of b. So b is 6. Half of b would be 3, and we have to square it. We square it on the inside, we added it, square it on the inside, and we subtract it squared on the outside. So the next step will look something like this. So we will have, let's put it like this, I could use a regular bracket still. So we'll have x squared plus 6x plus 3 squared. Good. Close bracket, minus 5 minus 3 squared. Notice I added half of b inside squared, so I subtract half of b squared on the outside. That is all that happened here. And once I finish this, it's a simple matter of solving. So inside the bracket, let me give you a hint. I'll give you a big time shortcut, but I will prove it for you anyway. Inside the bracket, you will always end up with x plus whatever half of b was. Whatever half of b was will be what you'll put inside here. So notice b was 6. Half of b was 3. Mind you, if b was a negative number, then of course this would be a negative number too. But one fact you should know, and I will prove it for you just for those that may want to see it. But one fact you should know is that once you're completing the square, whatever half of b was or is will come here when you finish. And on the outside, you'll see that you'll have 5 minus 9. Good? 3 squared is 9. And let me put this differently. Let me write it like this. Because I've seen students believing that it's minus 3 all squared. And as a result, when you square it, you end up getting 9. Because you say, okay, minus 3 times minus 3 is positive 9. But no, you are subtracting the entity of minus 3. Sorry, the entity of 3 squared. So you cannot double up on this negative sign to make it positive. So my final answer here would be x plus 3 all squared minus 14. Just like that. Minus 5 minus 9 is equal to minus 14. And let us just again prove this little bracket here. Only this one I will prove just for you to see how it works out. But again, just remember what I said. Whenever you get half of b, whatever half of b is, that is what will come inside of this bracket with the x all squared. Good? But for this one again, I will prove it for you. So let me just simplify this section here. I'm going to simplify this section here over here. So look at it. I will have x squared plus 6x plus 9. Check. 9 will be 3 squared. And again, I'm using the AC method here of factorization. Simple. I'm using the AC method. So I'm looking for 2 factors of 9 that could give me b. So remember, you're finding AC, and AC is 9 because we have a 1 here. So 1 times c, that's 9. And then we're looking for 2 factors of 9 that could give us b when we add or subtract. And in this case, we could jump straight to 3. 3 3s are 9. 3 plus 3 is 6. So we have x squared plus 3x plus 3x plus 9. And then I factorize by grouping. And in this bracket here, my common factor is x. So I will have inside here x plus 3. And in the next bracket, my common factor will be 3. Not common factor, yeah, common HCF. So here I'll end up with x plus 3, which is the same as x plus 3 and x plus 3, which ultimately is the same as saying x plus 3 all squared, which is what we have here. So again, if you want, you could work it out. That's up to you. But I'm telling you, because I've proven it over and over again, it will be a fact that you will always end up with, inside here, you will always end up with whatever half of b was. Just remember that. Whatever you got to be half of b, it goes here. I keep emphasizing that. Let's do another example. This one I'll do a little faster. I'll try to spend less time talking. I'll just apply the rule. So first thing again, we pair our x terms. So we pair our x terms. Second step, we find half of b, we square it to add on the inside, and we square it to subtract on the outside. So that would be x squared plus 4x. Half of b, remember b is the coefficient of the x term. Half of b, in this case, would be 2. So that will be 2 squared. Minus on the outside, 3 minus 2 squared. And let me put it in brackets so we understand we're squaring that entity. And at the ending of the day, we have here x plus 2 all squared. Remember, whatever half of b was will end up inside here. Or if you want, you could just go and work on this and simplify it, and you will see you'll end up with the same thing. And on the outside, we would have had minus 3 minus 4. Good, 2 squared is 4. So our final answer here would have been x plus 2 all squared minus 7. Minus 3 minus 3 minus 4 is minus 7. And of course, if this was equal to 0, we could go ahead and find out or finalize our roots also from this part of the equation, right? But I am focusing on that today. That's a simple thing to do. Good. So here now you have 3 examples. So here you could pause the video and go ahead and do them on your own if you can. Of course, I will move on right ahead, but you could pause here and solve them. So let's look at the first one here. So here again, simple thing, start. I pair my x term. After I pair my x term, I find half of b. So that will be x squared plus 8x plus 8x plus my half of b, in this case here, would be 4 squared. I add that on the inside. Put my brackets on the outside there. Let's put this bracket. So 4 squared. How did I get this 4? 4 is half of 8. And half of 8 squared, add it on the inside. And on the outside, I will do the same thing. So it's minus 9. But what I add on the inside, I take away on the outside. So on the outside is minus 4 squared. And that's how I end up with that. And my last rung of working out, remember, inside the first bracket here, we'll always have the x and whatever half of b was. So that will be 4 in this case. Minus, we're solving on the outside now, 9 minus 16. So ultimately our answer here was, or should have been, x plus 4 all squared minus 25. And that's basically it. That's completing the square. I mean, to be honest, completing the square is very easy. What, however, I think is a problem, and I ain't lying to tell you, is when we're dealing with fractions. I'm not sure if I put a fraction here. Oh, yes, well, look at it. I talked too soon. So here we have a fraction popping up. So again, let's just follow the concept. Let's follow the concept. So we pair our x terms. After I pair my x terms, I find half of b. Half of b in this case here would be a fraction. So notice I would have x squared minus 5x plus, now I will have 5 over 2, yes, all squared. That's my half of b. So how did I get 5 over 2? Remember, a half multiplied by 5 over 1, because 5 is b. 5 is b. So I'm trying to find half of b. And half of b in this case will be 5 over 2 because it cannot break down any further. Just following the rules. And on the outside I have plus 3 minus, again, 5 over 2 all squared. And these are those that usually throw off students. But again, it's simple. Just follow the rules. Just follow the rules. So again, remember outside now, or when we're solving now, we have x plus whatever half of b was is what will come inside here. So in this case, it's 5 half. And outside now, we have to do a little arithmetic there. So let's solve the outside. On the outside, I have 3 minus, so let me put 3 over 1 minus 25 over 2. That's what we really would have on the other side. And to simplify this, I'll just multiply this section here by 2 to make the common denominators. So that will give me 6 over 2 minus 25 over 2. And if I solve this, 6 minus 25, that should give me negative 18 over 2. And negative 18 over 2 is the same thing as negative 9. So when I solve this whole, what seems like a callaloo soup outside here, you will simply get negative 9. And this is our answer. This checks out. So don't let the fraction throw you off. Just do your maths. Take your time and work your thing properly. Oh, no, 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 no. I made a mistake. I made a mistake. I made a mistake. I just see my mistake. 5 minus 25 is not 18. No, sorry about that. That's actually 19. Speaking, well, while I'm speaking and looking back at my work, yeah, that's negative 19. So the final answer will be that. The final answer will be minus 19 over 2. Yes? 19 plus 6 is 25. So 6 minus 25 is 19. Negative 19. This is positive. This is negative. So as the rule goes, take away the smaller from the larger one, but you keep the sign of the larger one. So yes, the answer is this. Sorry about that. Hope you got it right and not wrong with me the first time. So if you had negative 9, you're wrong. Yeah, I thought 5, 6 minus 25 was 18. I thought I had to end up with a perfect answer. At least that's what I was looking for. But no, it doesn't always work out like that. So yeah, this is it there. Let's try. I think we have one more. Right, we have one more. And look at this one. This one will end up with a fraction too. Once I see B and I see that B is a odd number, I know that I will end up with a fraction by default. Right, so again, following the procedure, I bracket my x terms. And after I bracket my x terms, I am trying to find half of b. So again, big brackets, and I go x squared minus 7x plus, and in this case, half of b will be negative 7 over 2, all squared. Good. How did I get that? Again, just like the previous question, a half times 7 over 1. Nothing here could break down, so half of 7 is 7 over 2. And please leave it as a fraction. I've seen students sometimes do 3.5. And yeah, 3.5 is not wrong, but it makes it harder to calculate when you reach on the outside because then you're dealing with a fractional value, a decimal. It's easier to work with the fraction because a fraction gives the whole worth of the number without taking away anything from it. So minus 7 over 2. Sometimes some decimals you have to cut it short because it's too many places. Although I'm not sure, or supposing you end up with a case where you have you end up with an irrational. I know, imagine we end up with an irrational number, a number that cannot terminate. And if we use decimal places, then you know we are already removing some of the value of that number. So please, whenever possible, work with the fraction as much as you can. So here now we have x minus now 7 over 2. Remember, whatever half of b was, you throw that inside there, and that's all squared. And on the outside, let's see if we could work out this. Let's see if we could work out this here. So that will be positive 4 over 1 minus, when I square inside here, everything else will become positive, right? So that will be 49 over 4. Good? 49 over 4. 7 squared are 49, so 7 times 7 is 49. 2 times 2 is 4. And here I want common denominators, so I will multiply here by 4, and I'll multiply the bottom here by 4. So that will give me 16 over 4 minus 49 over 4. And now that my denominators are the same, it's just a matter of subtracting the top. So remember the rules, take away the smaller from the bigger one and keep the sign of the bigger one. I don't want to make the same mistake from earlier, so I'm working it out here. So here I have 3, then I have what? 3. So 33, my answer will be negative 33. So my answer will be negative 33 on 4. So outside here, I'm supposed to have negative 33 on 4. And that's as low as we go. I mean, it looks messy. Well, I mean, if you want, I guess you could always change that to a mixed fraction. So if you have x minus 7 over 2 all squared minus what? This will be 8 and a quarter. Yeah, I guess if you want to put it like this, I would think it's fine. So long as we stop in there, there's nothing else to worry about. However, if we're trying to find the minimum or the roots of x, I suggest we leave it as 33 over 4. So yes, that should bring us to the end of today's video. That's basically the gist of completing the square. Tomorrow, God willing, we're going to do the same thing, but we're going to look and see what do we do when a is not equal to 1. So when there is a value, when there is a number for the coefficient of x squared, how do we go about doing it? And again, it's a simple process, but I'll reveal that tomorrow, God willing. So until then, you take care.